Cool. All right, my name is Tim. I'm an engineer. I work at a company called Strava. We are a platform for athletes to track and share their athletic activities. So we aim to connect athletes to what motivates them and help them find their personal best. So before I jump into my talk today, we hit some pretty big milestones this year. I want to share some. I'm super excited about it. I want to share some of them with you. So our athletes to date have uploaded over 2.5 billion activities onto our platform. So in the time that I've been presenting this slide, our athletes have uploaded over 500 activities. That's about 25 activities per second. Now, speaking of athletes, we have over 45 million of them, and we're adding 1 million new per month. We really are a global platform with over 82% of our athletes living outside the United States. So hopefully that gives you some sense of the scale that we're operating at and can kind of feed into the discussion as we move forward. So a bit about myself. I am an engineer focused on iOS. I work on the growth team, and my favorite activity is running with my little 30-pound border collie dog. So some of the things that I've worked on at Strava include rebuilding our new athlete onboarding flow from the ground up. We built this fun server-rendered sharing page to share your activities to social platforms, and leading the effort to modularize the growth team's portion of our code base. So today I'm here to talk to you about networking on iOS. Now, I want to start with some prompts. So raise your hand if you have a phone that's connected to the internet. I expect everybody to raise your hands. Now my next question is, raise your hand if you've ever experienced a network error in your app. Do you remember how frustrating that was? Like maybe you're trying to send an iMessage or like a GIF or find a GIF or download a photo or a GIF that someone sent you. Whatever it was, it didn't work. And it was just extremely frustrating. There's nothing you could do about it. It's almost like you're paralyzed. Now in the United States, we have the privilege of having highly available and fast internet. But in places like Brazil or India, this experience of having those frustrating times is much more frequent and commonplace. Networking is at the center of the applications we build. At its core, it's how we connect with one another in this room. It's how our applications live and breathe. Now let me ask you a question. Would you ever go 5 years without buying a new pair of shoes?
Yes!
I hope not. I mean, your networking infrastructure should be cared for as much as you do for your own 2 feet. Now, I know we all have different standards, but I hope it's at least something. So now I want to give you an overview of what to expect from this talk. The first being, I want you to learn how to build a modern API client on iOS. And the second being, I want you to learn from my experience of navigating the conversation around whether or not to use a third-party library. And lastly, I want you to learn about the strategies I use to mitigate risk and replace our entire networking stack over the past year. I've learned that storytelling is a great form of communication, so the rest of this talk is just going to be a story over the past year of how I've done these things. So hopefully you'll learn these 3 things. Well, let's get to it. So there's 3 parts to my story. The first, a little bit of history about Strava, a little bit of history about networking on iOS. Second bit is a deep dive into how I approached building this new API client with a little bit of touching on what the actual code looks like. And then the last part, is all about how I went about replacing our network stack over the past year. So let's get started with the backstory. In 2009, Strava was founded as a web-only cycling product. It was geared towards people that had fancy, expensive GPS devices that went out and rode their bike, had a file with a bunch of GPS points in it, and they wanted to upload it and analyze it. So in 2011, Strava decided that they wanted to target a broader audience and began working on an iOS application. Same target audience, just that they wanted you to be able to use your phone to record your rides and kind of get the same experience. 2013 was the last time any major changes were made to the API client for this app. Now, at the time, we used AF networking, pretty easy trade-off, startup, building a new application, made a lot of sense. Later in 2013, Apple introduced NSURLCession. It was an improvement upon NSURLConnection, and it just greatly, in general, improved the networking capabilities on iOS. And then in 2014, they introduced Swift. Now, I think it's safe to say that this was a smashing success, considering we're all here today talking about all kinds of fun things. And then in 2017, Apple introduced Codable and then JSON decoder. Now, Codable is a protocol that enables automatic decoding and encoding and decoding of objects. And JSON decoder is its pair that automatically deserializes JSON into those objects that conform to Codable. Now, I joined Strava in 2018, and I saw this opportunity. Strava didn't really have a lot of Swift code at the time. Not a lot of people with experience were there. I kind of came in and I had all this knowledge of these tools, and I started to ask this question of, do we really need a third-party library for this still? It's 2018, we've got to get with the program. So we were using AF networking, like I said. A ton of people were using it. But let's take a look at one of our network requests. This is a request that updates our athlete data model. In the beginning, this was probably 3 lines of code. But over the course of 5 years, as we added more and more properties and things changed, you can see how it grows. It's kind of gross. So at over 40 lines of error-prone code here, I saw a lot of room for improvement. Now, coming back to this question of, do we still need a third-party library for this? There's a couple things going through my head. And the first is, how stable is the library that we're using? Is it causing crashes? Is it wasting memory? Is it still being actively maintained? No, in the case of AF networking, still kind of being actively maintained, but the answer to this question is yeah, it's pretty stable. But the question that really came into play here is, what is the cost of ownership for this particular function? So this is the bigger point that I'd like to make, and I'm going to expand on this a bit. So there's kind of a couple questions in this broad category that I was thinking about. The first being what is the time investment to build and maintain this ourselves? How long will it take to build initially? How long will it take on average to maintain on a continuous basis, being maintenance including improving the system, because you can't just let it sit. Now, given the advancements in URLSession and Codable, I determined the time investment for this project was only a couple weeks on the side at best. So the second kind of question I asked was, do we have the resources to maintain and improve this? We know what the time is, but if we don't have anybody that has the time to do it, then what's the point? So in the case of Strava, I took this project on by myself. All of us iOS engineers are responsible for the health and maintenance of our platform. So kind of on the side, 10, 20% of my time every week was working on this. The last question was, are there any clear benefits to owning this thing in its entirety? What will we gain by investing time into this system? Gaining more control over a system that is so fundamental to our application is just a huge win in of itself. But for Strava, we lean on networking even more so for our users that are out trail running with poor network connections, that are trying to upload files of their GPS files of their activities. There's a lot of out and about scenarios that we encounter more often. So circling back to this question of whether we still needed a third-party library or not, and in 2011, it made a lot of sense to continue using that, to use a library, because the time investment trade-off at the time just wasn't there. But as you've seen over the years, that table started to turn. As the application matured, our needs started to change, and in 2018, it just made a lot of sense. The answer to this question became no, not at all. We really don't need a third-party library. There's 2 big things. Cost of ownership significantly decreased. The advantages of URLSession and Codable really changed the economics in our favor here. And second being, owning this core part of an infrastructure is very important to Strava. Even it's more so as we continue to grow into a global platform in the years to come. We wanted our future to be fueled by our infrastructure, not to be limited by it. So at this point in my story, I decided it made sense to rewrite this system. So I'd like to dive into how I approached this and kind of go with the goals that I went into it with. So the first being, you saw that 40-line request, a network request that I showed earlier. I wanted this new system to be incredibly easy and straightforward to use, and I wanted it to be that way because I wanted my colleagues to have a no-brainer answer, decision to use this one, because it's quicker, easier, and more straightforward than the old one. The second is I wanted it to be extensible. I wanted the system to be easy to be changed and upgraded and new functionality to be added to it. The last API client lived for over 5 years. There's a high likelihood that this one will live just as long. And I didn't want us to be in a situation again where we had some rough waters. So the last thing is I wanted it to be extremely testable. I wanted to test as much of it as possible. We value unit tests a lot at Strava as this helps us consistently deliver high quality experiences. So let's dive into that first goal of usability. What does the interface look like for making a request? Now, we have this object post, pretty small, but you can see that it conforms to decodable. And it just has some raw data types, integer and string. So we want to hit an endpoint and retrieve a list of posts. So we'd start by creating this API request object. It's just basically an object that wraps some metadata about the request, has like the method, the path, etc. And then we feed that into our API client. This perform method will take that request and return the Swift result enum, a result, success or failure, and a block. And so in that success case, we get back this response object. Now the response object has just some metadata about the response, including the response body. So from there, we take that response and we can decode that into our list of posts. And that's it. That is the 40-line difference now that we've reduced to just a handful of lines of code using all these new tools that have come about. So let's jump into the second goal of extensibility. Now, if you've ever heard of the solid principles, I'm a huge fan. Single responsibility principle is really where I came at this with. Extensibility means building a system in a way that allows for future growth. So by separating everything out into small individual components, it made a lot more sense on where things should go. So looking at each of these components, we've already seen API request. This object just encapsulates the metadata for the request. Here's the code for it. There's a couple other methods down below that are basically the same as these initializer methods that modify this request and just add some more information to it. But the biggest thing to note is that second initializer method that takes advantage of JSON encoder to add a custom request body. The second component is network service. Not going to dive into this too much, but the gist of it is it's just like an abstract wrapper around URLSession. The line that we really care about is this one here. That's that interface URLSession. Pretty standard, enables us to just abstract that entire thing from our system. The third is API response. As we kind of saw, this just encapsulates information about the response, being the status code and the body, whatever type we end up making that. So we kind of saw that decode method being used earlier to decode that list of posts. Now, the implementation here is actually relatively short, given all of these, given Codable and JSON decoder. It allows us to quickly decode that type that we're feeding in. We fed in that list of posts. And then if it succeeds, we return a new response with that actual object. So the last part of the system is our actual API client, which in reality, this client is pretty dumb. All it does is pull all these components together and acts as just a single interface for the consumers of it. So I purposely left out the implementation because there's really not much to it. The most important thing here is just the interface that you use to interact with it, this perform method. So the best thing about this, and the other reason I left out the implementation, is that you can customize it to your needs. So for example, at Strava, we wanted to implement distributed tracing across all of our requests. And it was extremely easy to just add a couple lines of code to our API client implementation, and out of the box, boom, we had it on every request. So I'm going to jump through this one. Unit tests are boring, but it's still important. My main goal here for increasing the testability of this was to have a thoughtful interface design and to use protocols to be able to mock things. So that's example request. We're testing API request, essentially because all that object is doing is just storing some information, made it extremely easy to test that it was doing it properly. Second unit test was just really because we abstracted our network service. We were able to create a mock version of it and simulate an actual successful network request and then test that the API client was actually doing what we expected it to do. Cool. So we talked about the history and how we got here. We talked about what goes into building this client and how we built it. So now we have this thing, what do we do with it? Well, the first thing that we did at Strava was we said, well, after we made sure that everything worked, we said all new requests are going to go through this new system. But the problem is now we have two systems, and one has hundreds of requests going through it, one is a brand new system, and there's really not any benefit to manually rewriting the old requests nor maintaining both systems. And Codable is not compatible with Objective-C, so we couldn't just use the new one everywhere. And maintaining two separate API clients is just a complete headache. So the solution here was to build a bridge to merge them together. Our old API client had its own protocol that defined its interface. So all of the consumers of it had all of these functions, its own implementation conformed to this protocol. So the solution here was we created this new object that conformed to this protocol but used the new API client under the hood. So this allowed us, with one line of code, to switch the API client that a particular class was using. So the goal was then to slowly divert traffic from the old bridge to the new one. But we had a lot of networking code. As you can see, we have hundreds of network requests. So over the past year, it started out like this, with very few requests using the new system. And then each week, we would kind of flip a few switches, add some new requests to go through the new system, and slowly it started looking like this. It didn't take much time, just more about managing the risk of changing that much underlying code in our code base throughout time. So after 1 year, things started to look like this, and we were basically completely transitioned to our new API client. But it really wasn't that simple, as simple as those slides make it, because unexpected things are guaranteed to happen. It's never going to work exactly how you expect it to. And we should be able to upgrade our systems without fear of our users feeling the impact of this. So let's look at an example of something that went wrong. We have this screen that allows you to update your profile, particularly if you look at the top left, there's that profile photo. If you tap on it, it lets you change your picture. If we go back to this nasty API request, you kind of look through, there's a lot of properties here, but there's one in particular that is really nasty. It's this image one. So our old implementation was feeding this UI image object into the API client, and AF networking under the hood was deciding if this UI image is in this parameters dictionary, we're going to send a multi-part request. But if not, we're just going to send a normal one. Completely unobvious when reading through this. And I didn't catch it, to be honest. But luckily, I anticipated something like this happening, and I had a system in place to catch it. The solution was a server-driven toggle that allowed us to flip back and forth between both API clients. So when something goes wrong like this, we can just switch back that toggle, and within minutes, we can go back to using the old API client. So when a new version of Strava is released and my colleagues see a graph that's going up and to the right with crashes, this toggle really came in handy. Within 15 minutes of this massive spike, we were able to turn it off and prevent the incident from getting any worse. So hope that is helpful. The takeaways from this talk that I'd like you to walk away with is mostly just one, be careful with using third-party libraries, be thoughtful about it, make sure it makes sense for you and your application, and two, invest in your core infrastructure to fuel your future. Don't be afraid to do that. It shouldn't be holding you back. You should be pushing that code to help push yourself forward. Thank you. If you have any questions, I'll be around. I think we have a couple minutes, but.
It's just Strava ID.
My Strava ID? I think it's /tim-Miko. If you go to my website, I'm sure you can find it from there.
Is your kill switch, was it implemented just like on Strava?
Yeah, so the way that system works is we have a list of server-side toggles that are defined locally in the client, and then on startup they're fetched in the background, so then they get cached, and there's a whole system in and of itself, but yeah.
So did you guys have to deal with any tricky enough issues like auth2 or SSL or
With switching or?
switching like with your own networking library?
Not in particular. I mean, a lot of the stuff that we were doing, like SSL pinning, for example, like that stuff, we were able to migrate over pretty easily. Cool. Well, thank you all. I'll be around. If you have any questions, don't hesitate to come up and grab me and chat. Thank you.